Right now, it feels like you're touching something. Your phone, your desk, the fabric of your clothes. It feels solid, direct, certain. But here's the part that sounds impossible. You have never actually touched anything in your entire life. Not once. Not physically. Not in the way you think. Because at the deepest level of reality, there is always space between you and everything else. And what you call touch is something else entirely. Something stranger. Something invisible. Something happening without contact at all. Tonight, we're going to slow this down and step into the exact moment where your finger meets an object and see what's really happening there. Because once you see it clearly, you don't just understand touch differently, you start to see reality itself differently. Take your finger and press it lightly against a surface, a table, your screen, anything near you. It feels simple. Your finger moves forward, and then it stops, as if it has made contact, as if two solid things have met. But that moment, that exact point where you believe contact happens, is not what it seems, because your finger never actually reaches the atoms of the surface, not in the way you imagine. Instead, something stops it before it ever gets there, an invisible barrier, not made of matter, but of force. At the atomic level, both your finger and the surface are made of atoms, and atoms are mostly empty space, tiny nuclei, surrounded by clouds of electrons. And those electrons carry electric charge. So as your finger gets closer, the electrons in your skin and the electrons in the surface begin to interact. They repel each other, not gently, but powerfully. And that repulsion is what you feel. Not contact, not pressure between solid objects, but electromagnetic force, pushing your finger back, preventing it from ever truly touching the surface. So the sensation you've always called touch is actually resistance, a force interaction, a push without contact. And it happens every time without you ever noticing. If you could zoom in, past your skin, past the cells, past the molecules, into the atoms themselves, what you would find is not solid, not dense, not packed together. You would find space, almost entirely. An atom is not a tiny solid ball. It's more like a structure, with a dense nucleus at the center, and electrons existing in a kind of cloud around it. And between those two, there is distance, a lot of it. If an atom were the size of a stadium, the nucleus would be a tiny grain at the center, and the electrons would exist somewhere near the edges. Everything in between? Empty. So when you press your finger against a surface, what's really happening is this. The atoms in your finger are approaching the atoms in that surface. But because both are mostly empty, there is no solid wall they run into. Instead, their electron clouds begin to overlap. And as they do, forces begin to build. Electromagnetic forces, repulsion. And that repulsion grows incredibly strong, incredibly fast, strong enough to stop your finger completely, long before any physical collision could happen. So what feels like solidity, what feels like a hard, definite boundary, is actually a field interaction, a balance of forces, a region where atoms resist being pushed closer together. And this is happening everywhere. Every object you see, every surface you touch, every step you take is built on this same principle. Not solid matter meeting solid matter, but fields interacting with fields, pushing, holding, stabilizing, creating the illusion of contact. So the world doesn't feel empty, it feels solid, even though at its core, it's almost entirely space. At this point, a strange question starts to form. If nothing ever truly touches, and everything is mostly empty space, then why don't things just pass through each other? Why doesn't your hand slide straight through a table? Why don't you fall through the floor every time you stand up? Because if there's space between atoms, it should be possible, right? But this is where the idea of empty space becomes misleading, because even though atoms are mostly empty, that space is not inactive. It is filled with something just as important as matter itself: fields. Every electron in your body carries a negative electric charge, and every electron in the surface you touch carries that same charge. So as soon as those atoms get close enough, those charges begin to interact, and not gently. They repel each other with incredible strength, much stronger than gravity, much stronger than anything you experience in everyday life. And that repulsion doesn't wait for atoms to collide. It begins before they ever get close enough for that. So as your hand moves toward a surface, the closer it gets, the stronger the repulsive force becomes, until it balances out your motion, until it stops you completely, not with a sudden impact, but with a smooth, invisible resistance that builds so quickly it feels instant. So you don't fall through the floor, not because it's solid in the way you imagine, but because the electromagnetic forces between atoms are preventing that from ever happening. Your entire physical world, everything you interact with, is held together by this balance: a constant push, a constant resistance, a structure made not of contact, but of interaction. And once you understand that, the idea of solidity begins to change. It's not about things being filled. It's about forces holding everything in place. If there is no real contact, then why does it feel so real? Why does pressing your hand against something feel solid, immediate, undeniable? The answer isn't in your finger, it's in your brain. Because what you experience as touch is not the physical event itself. It is an interpretation, a signal, translated into something meaningful. When your finger approaches a surface, those electromagnetic forces begin to push back. That force creates pressure in your skin. Tiny structures called receptors detect that pressure. Some respond to light touch, others to deeper force, others to vibration or temperature. And the moment they are activated, they send signals, electrical signals, traveling through nerves, up your arm, into your brain. And your brain does something remarkable. It takes those signals, those raw electrical patterns, and turns them into an experience, not a force, not a field interaction, but something familiar, something intuitive. Touch, a surface, a boundary, a sense that something is there and that you are in contact with it. But that feeling is not the event itself. It is a constructed experience, a model, your brain's best attempt to make sense of invisible interactions. And it does this constantly, not just with touch, but with everything. Sight, sound, taste, all of it is interpretation. All of it is your brain turning complex physical processes into something you can understand. So when you feel something solid, you are not feeling atoms touching. You are feeling your brain's interpretation of forces preventing them from doing so. And that distinction is easy to overlook. But once you see it, it changes everything. Because it means your experience of reality is not a direct copy of what's actually there. It's a translation. Now imagine something unsettling for a moment. Take away those forces, not gradually, not weakened, but completely gone. No electromagnetic repulsion, no resistance between atoms. What would happen? At first, it might seem like things would just become softer, less solid. But the reality is far more extreme, because without those forces, There would be nothing preventing atoms from moving through each other. Your hand would not press against a table. It would pass through it. Not slowly, not with resistance, but instantly. There would be no boundary, no surface, no stopping point, and it wouldn't just be your hand. Everything would lose its structure. Your body, the air around you, the ground beneath you. All of it depends on those interactions to maintain form. Without them, atoms would no longer hold their positions relative to each other. Matter would not behave like matter. It would not feel solid. It would not resist motion. It would not form stable objects at all. In a sense, the world as you know it would dissolve, not explode, not collapse, but lose the very property that makes it recognizable: structure. Because structure is not just about what things are made of. It's about how those parts interact, how they push, how they hold, how they prevent overlap. So when you feel something solid, you are not just feeling matter. You are feeling stability, a balance of forces that allows things to exist in a fixed form. And without that balance, there is no touch. There is no surface. There is no physical world in the way you understand it. At this point, it almost feels like there should be a loophole. If everything is mostly empty space and atoms never truly touch, then shouldn't there be some way, some rare moment, where things could just pass through each other? Where your hand slips through a wall like nothing is there? But that doesn't happen. And the reason is deeper than just force. It's also about the rules that govern how matter exists. Because electrons are not just tiny charged particles. They also follow something called the Pauli exclusion principle. And while that might sound abstract, its effect is very real. It means that two electrons cannot occupy the same state in the same place at the same time. So when the electrons in your hand approach the electrons in a wall, they don't just repel each other. They are also restricted from overlapping in a deeper, more fundamental way. It's not just they push each other away. It's they are not allowed to exist in the same configuration. And this adds another layer of resistance, another layer of structure. So even though there is space inside atoms, that space is not freely accessible. It is governed by rules, rules that define where particles can be and where they cannot. So when you press your hand against a wall, you are encountering both electromagnetic repulsion and quantum restrictions, working together, preventing overlap, maintaining structure. And this is why walking through walls is not just unlikely. It is effectively impossible under normal conditions. Not because the wall is solid in a simple sense, but because the laws that define matter do not allow that kind of overlap to occur. So the emptiness inside atoms is not an open door. It is a structured space with boundaries you cannot cross. After everything you've just followed, it would be easy to fall into a strange conclusion that nothing is really solid, that nothing is really touching, that everything is just empty space and invisible forces, and in a strict physical sense. That's true, but your experience doesn't feel that way at all. The world feels stable, reliable, solid, and that's not a mistake. It's not your brain being wrong. It's your brain doing exactly what it's supposed to do. Because your brain is not trying to show you reality as it is, at the smallest possible scale. It's trying to show you reality in a way that is useful, in a way that allows you to move, act, survive, and interact. When you press your hand against a surface, you don't need to perceive electron clouds or electromagnetic fields. You need to know one simple thing. This is solid. I can't move through it. So your brain compresses all of that complexity, all of those invisible interactions, into a single, clear sensation. Touch, pressure, resistance. Something is there. And that simplification is incredibly powerful because it allows you to function in a world that would otherwise be too complex to navigate. So when you feel something as solid, you are not being misled. You are experiencing a translation, a higher level version of reality designed for interaction, not for precision at the quantum level. And that's why everything feels so real, because at your scale, it is. Even if, beneath that layer, reality is far stranger than it appears. Up until now, everything has pointed in one direction. You can't pass through objects. Atoms don't overlap. Forces stop you before contact. But at the quantum level, there is a rare exception, something that seems to break all of those rules. It's called quantum tunneling, and it allows particles, under the right conditions, to appear on the other side of a barrier, without ever crossing it in the classical sense, not by pushing through, not by breaking the barrier, but by simply being found on the other side. At first, that sounds impossible, like something from science fiction, but it's real. It happens all the time on very small scales, inside atoms, inside stars, even in the processes that allow the sun to produce energy. So how does it work? At the quantum level, particles are not fixed points. They don't have a single, precise location. Instead, they are described as a spread of possibilities, a kind of probability cloud. So when a particle approaches a barrier, there is a small chance that part of that probability exists beyond it. And if measured there, the particle appears on the other side, as if it tunneled through, without crossing the space in between. Now here's the key point. For something as small as an electron, this probability can be significant. But for something large, like your hand, it becomes unimaginably small. So small that it effectively never happens, because your hand is not one particle. It is made of trillions upon trillions of atoms. For all of them to tunnel at the same time, in the same direction, is so unlikely that it will not happen within the lifetime of the universe. So quantum tunneling shows that the rules are not absolute, but it also shows something else. That scale matters. What is possible for the smallest particles does not translate to the world you experience. And that's why, even though reality at its deepest level is flexible, your everyday world remains solid, stable, predictable. What you just realized about touch doesn't stop there. The same principle applies to everything you experience, not just what you feel, but what you see, what you hear, what you believe is directly out there in the world. Take vision, for example. It feels immediate, as if you are simply opening your eyes and seeing reality as it is. But what is actually happening is far more indirect. Light reflects off objects, travels through space, and enters your eyes. Inside your eyes, that light is converted into electrical signals. Those signals travel through nerves into your brain. And then your brain constructs an image, color, shape, depth. All of it is created internally, not projected outward. So when you see something, you're not directly observing the object itself. You're experiencing your brain's interpretation of the light that reached you. And hearing works the same way. Sound is just vibrations in the air, pressure waves. They reach your ears, are converted into signals, and your brain turns them into tones, voices, meaning. So the world you experience is not raw reality. It is a processed version, a model, built from signals, interpreted into something coherent. And just like with touch, that model is incredibly effective. It feels real, consistent, reliable, but it is still a translation. So when you look around, what you are experiencing is not the world directly. It is your brain's best reconstruction of what's out there. And once you see that, something shifts because it means that everything you know, everything you feel is real, is already one layer removed from what's actually happening underneath. After everything we've explored, touch not being contact, matter being mostly empty, your senses being interpretations, a deeper question begins to form. If none of this is exactly what it feels like, then what is reality really? Is anything actually solid, actually there, or is everything just an illusion? It's tempting to go in that direction, to think that if your senses don't show you the raw truth, then nothing is truly real. But that's not quite right, because what you're experiencing is not false. It's a simplified layer, a useful version of reality. Think of it like a map. A map is not the landscape itself. It doesn't show every detail, every grain of sand, every molecule. But it shows what you need to navigate, to move, to understand where you are. Your perception works the same way. It doesn't show you atoms, fields, or quantum states. It shows you objects, surfaces, boundaries, things you can interact with. And that's exactly what makes it powerful. Because if you were exposed to reality at its deepest level, all the time, you wouldn't be able to function. It would be too complex, too chaotic, too detailed. So instead, your brain presents a version of reality that is stable, coherent, and actionable. And that version feels completely real. Because at your scale, it is. So reality is not an illusion. It's layered. What you experience is real, but it's not the full picture. It's one level, built on top of something much deeper. And once you understand that, you don't lose your sense of reality. You expand it. Right now, your body is resting. Your hands are still. And it feels like you are in contact with the world around you. But beneath that feeling, there is space. There are forces. There are interactions happening without contact. And they are always there, quietly shaping everything you experience. Every surface you touch, every step you take, every moment of physical interaction is built on that same invisible foundation. And maybe there's something calming in that the world you move through is not made of rigid, solid blocks, but of relationships, forces, balances, structures that hold without ever truly touching. So as you begin to relax and let your thoughts slow down, you can let that idea settle, that even when everything feels solid, there is space. Even when everything feels direct, there is something deeper beneath it. And that deeper layer is always there, quiet, stable, holding everything together. And if you enjoy exploring ideas like this, slowly, calmly, and in depth, then you're in the right place. This is science sleep theory, where the deepest ideas in science become something you can simply drift into. Sleep well.